Welcome friends and all other dear students. In this video we will learn the degree of freedom introductory concept. Okay. So there is another term that is mobility, which is generally confusing with degree of freedom. So generally degree of freedom is defined as the number of independent coordinates to define the position of any devices or links. Okay. But mobility is defined as the number of independent parameters that are required to be controlled to define the exact position of a link or mechanism. So that is the basic difference between degree of freedom or mobility. Okay. So degree of freedom generally calculated. So degree of freedom of a rigid body. So rigid body is defined as the body which does not undergo any deformation while transmitting motion. So actual body is not generally the rigid body, it is called the semi-rigid body because slightly deformation always take place when applied any motion. So generally the rigid body which have total 6 motions, that is 3 translatory motions and 3 rotary motions in x and y and z direction. Okay. So this one is 3 independent translation motion along 3 perpendicular direction x axis. Suppose this one is x, y and z. Okay. So 3 translatory motions and 3 rotary motions along x, y and z. That means it can rotate in x direction, it can rotate in y direction and it can rotate in z direction. Okay. So in free space we can say that if there is no restriction, so the degree of freedom in free space defined by DOF will be equal to 6 if there is no restriction. Okay. But if there is any restriction applied in a mechanism, because there is always, because consider any space not considered in space, it will always in plane, or we can consider in a plane mechanism. So general degree of freedom, if there is restriction applied, then degree of freedom with restraints or restriction is given by 6 minus number of n, and where is n is number of restraints. Okay. So now this is all about the degree of freedom of a space when there is no restriction applied. So now another case, degree of freedom of a mechanism. Before whatever case I discussed, 6 minus number of restraints is condition for spatial mechanism. Okay. One question arises, first of all we have to know what is mechanism. So when one of the links in a kinetic chain is fixed, then it is known as mechanism, because for a mechanism it is already defined by the one link have to be fixed, and there is another term considered, that is inversion. It is if the links are fixed alternatively, for example in slider crank mechanism, if one link is fixed first time, slider will be fixed, another time crank can be fixed. So different links will be fixed at different times, so this is called the inversion of a mechanism. But for simple mechanism, one link you have to be fixed. So generally degree of freedom for a mechanism is decided by the degree of freedom of the links constituting that mechanism. So generally I already told the two cases of mechanism. One is partial mechanism, another one is for plane mechanism. Spatial mechanism, that already degree of freedom is 6 minus number of restraints if the restriction applied. But for plane mechanism, examples of spatial mechanisms: robot arm, cranes, and hook joint, that is universal hook joints. Now consider the case of planar mechanism. So in plane mechanism, the link can be rotated in x direction or y direction, but it can be sliding in z direction. Okay. So if n, suppose in plane mechanism, if n is the total number of links, suppose small n is total number of links for a plane mechanism. So number of movable links is n minus 1. Okay. So without any restriction, the total number of degree of freedom for a planar mechanism will be equal to 3, because it can rotate in x and y direction, and two rotary motion and one translatory motion. So there are total 3 number of motions. So degree of freedom for a plane mechanism without restriction is 3. So accordingly, plane mechanism, if there is restriction applied, so this is called the zero order mechanism. If there is no restriction applied, restraint, first order, if there is one restraint, second order 2 general restraint, third order 4 general restraint, and third order 4 general restraint, and fourth order 5th general restraint. Means similarly different order according to restraint applied, according to the restriction applied. Okay, in a plane mechanism. So there are two criteria. One is Kurzbach criterion and the other one is Grubler criterion applied for calculating the degree of freedom. So let n is equal to total number of links in a mechanism, and f is the degree of freedom which has to be calculated for a particular plane mechanism. So in a mechanism, I already discussed, one link has to be fixed, so total number of movable links will be n minus 1. And P2 will be the number of pairs that have 2 degree of freedom. And one thing you have to keep in mind, when we consider about the motion in for a particular link or mechanism, there are basically two motions considered. One is completely constrained motion and another one is successfully constrained motion. Okay. So for space, the degree of freedom will be 6 and minus 1. And P1, let P1 be the number of pairs having 1 degree of freedom, and P2 will be number of pairs having 2 degree of freedom. Similarly, P3, P4 and P5, P6 having 6 degree of freedom. Okay. So automatically if there are total 6 degree of freedom, and if 1 restriction applied, there are remaining 5 motion applicable. So for 5 degree of freedom there is only 1 restraint, and for 1 degree of freedom there will be 5 restraints. So any pair having 1 degree of freedom will impose 5 restraints on the mechanism. So that it reduces the degree of total degree of freedom will be 5p1. 5 indicates the number of restraints, and 1 subscript indicates the 1 degree of freedom. Okay. So similarly for 2, 3, 4, 5, 6 are also. So the degree of freedom for plane mechanism is 6n minus 1 minus, when there is no restriction applied, so degree of freedom total 6n minus 1, this one. If there is one restriction applied, so remaining degree of freedom will be 5. If there are two restrictions applied, so 5p1, 4p2 minus 3 restriction, so 6 minus 3 will be 3. 3p3 minus 2p4 minus 1p5 minus 0p6. Okay, so this is the general formula for degree of finding degree of freedom in space if there are restriction applies. So accordingly, the number of whatever be the number of restraints applied or restriction applied, the degree of freedom will be reduced accordingly. Okay. Now, so the above formula is for finding degree of freedom according to Kurzbach criterion. Now Grubler criterion. Second one is Grubler criterion. Grubler criterion is applicable for plane mechanism. Okay, but Kurzbach criterion is applicable for spatial mechanism. Okay, so these points you have to be kept in mind. So if we apply the Kurzbach criterion to planar mechanism, so this equation is known as Grubler criterion. Okay. So I already told, for plane mechanism total degree of freedom only 3: 2 translatory motion and 1 rotation, or otherwise 2 rotary motion and 1 translatory motion. Generally we consider 2 translatory means x and y translatory motion and only rotation z direction in rotary motion. Okay, but it might be possible 2 rotary and 1 translatory motion also. So in both the cases the degree of freedom will be total only 3. Okay, so in the similar way like previous case, if there is no restriction applies, so total degree of freedom will be f equal to 3n minus 1. Now in the similar way, if there is one restriction applied, if number of restraint is 1, so p1 will be the number of pair having 1 degree of freedom. And p2 similarly number of pair having 2 degree of freedom, and p3 will be number of pair having 3 degree of freedom. Okay, so accordingly, if there is number of restraint is 1, so degree of freedom will be reduced to 2, and p3 will be number of links having 3 degree of freedom. So if there is one restriction applies, so the degree of freedom will be reduced to 2. So minus 2 p1 minus 1 p2 and p3 every 3 degree. There is no restriction applied. Here 2 restriction applies and 1. If there is no restriction applied, total number of motion is 3n minus 1. So according to Grubler criterion, the degree of freedom is defined as f 3n minus 1 minus 2 p1 minus 1 p2 minus 0 p3. So this is all about the degree of freedom For space and other I discussed the for spatial mechanism and another one for plane mechanism. I hope all of you will understand the concept of degree of freedom. I also told what is the basic difference between the mobility and degree of freedom. Thanks for listening. Okay.